Hello friends, this video on alcohol, phenol and ether part 11 is brought to you by examfear.com. No more fear from exam. Please pay some attention here, a little complex one. So here you get alcohol from primary amines. Please note, from primary amines only. You get primary alcohol. So what you do is, for example, I have C2H5 NH2. This is my primary amine. You react with HNO2, that is nitrous acid. Nitrous acid, you get C2H5, OH and nitrogen gas and water. This is what you get. This is ethanol. Now, and this reaction is also called diazotization reaction. Here the carbocation is formed and it's SN1 reaction. We'll tell you why. We'll tell you the reaction mechanism. This is SN1 reaction and this is SN1, so it's carbocation form. And to get HNO2, what we do is, we have seen this, we use this NaNO2 and we use this HCl. The product of these is nothing but NaCl plus HNO2. This is what we have seen in the past chapter. Yeah, you get HNO2, nitrous acid. The reaction is pretty complex. Let's see this. This nitric HNO2, if you see, is something like this. Correct? Now, H plus attacks on this. The lone pair of oxygen comes here. So what you get is OH, H, and this guy. So what happened is, here is, since this electron moved from oxygen to H, this will get a positive charge, this will get a negative charge. Negative and positive will combine, neutral, and this will get a positive charge. So end of the day, if you see, there is a positive charge on oxygen. But OH, this is H2O plus. It's a good living group. So it will leave. What will happen is, it will leave in this fashion. This bond will break, right? The electrons will move from here to here. Negative charge, positive charge. Negative and positive will neutralize. The positive charge will remain on NO, nitrogen actually. Correct? You get water out. This is called nitrosonium ion. Please note NO plus nitrosonium ion. Hope you understand till now. See, HNO2, HONO I had. H plus was reacted with this. Oxygen had the lone pair. Oxygen gave it lone pair to hydrogen. Oxygen derived a positive charge. Hydrogen gets a negative charge. It already had positive, negative combined. Hydrogen neutral, oxygen gets a positive charge here. This is what happens. H2O plus good living group. It leaves. The electrons move from here. This bond breaks. Electrons moves in this direction. Negative charge here, right? And positive charge here. Negative, positive combines, neutral. This positive is left on nitrogen. Correct? This is how you break the bond. You get NO plus. So now you have NO plus and water. Now I have my primary amine. So let's suppose I have RNH2, where nitrogen has lone pair of electrons, and I have NO. Correct? With a positive charge. So this lone pair of electron, positive charge. This lone pair of electrons will get attracted toward this positive charge. And what will happen is, nitrogen will give electron to this nitrogen. It will get negative charge, it will get positive charge, right? It will get positive charge, it will get negative charge. Positive and negative will neutralize. And end of the day, this nitrogen will have positive charge. So I'll show you this how it will work. Correct? This is how it will be. And now this nitrogen will get a positive charge. Hope you understood why. Because this lone pair of electron moved from here to here to form a bond. This gets negative, negative and positive cancel, and this gets positive charge here. Correct? So till this it is clear. Now there is a positive charge on nitrogen. We'll do a deprotonation here. We want to get rid of positive charge. I can do a deprotonation easily, directly, or you can have the reaction saying that H2O react and form deprotonation. I'll just do a deprotonation easily. Right? So this bond will break. Right? This bond will break in this fashion: negative charge, positive charge. Negative and positive neutralize, positive will be out, so H plus will come out. So I'll do a deprotonation, so I'll get something like this. Correct? Hope you understood what I did. It had positive charge, this is unstable. So I'm doing a deprotonation, breaking the bond in this fashion. So this gets a negative charge and this gets a positive charge. Sorry, this gets a negative charge, this gets a positive charge. Hydrogen gets a positive charge, nitrogen gets a negative charge. Nitrogen already have positive, negative neutralized, hydrogen positive charge came out. So you get something like this. Now we'll see something called tautomerization. Right? So this, now if you see, will go here. This bond will break. See what will happen is, oxygen is electronegative, it will take electron toward itself, slightly negative, slightly positive charge. This hydrogen will become H plus and will attack this oxygen. Right? So in that case, it will get a negative charge. So if you see overall what will happen is, you will get something like this. Correct? And I call this as tautomerization. Correct? So this is what you will get. Now, on this, we'll do H plus attack. There is OH here, we'll do H plus attack because we want to get rid of nitrogen here. So this is a critical equation here now. I'll do H plus attack. Now since it's H plus, oxygen had this lone pair of electron, oxygen will cling to this H. So what you get is Rn double bond NOH H, and oxygen will get the positive charge. Why? Because this lone pair of electron will move to hydrogen, hydrogen will get a negative charge, negative positive neutralized, oxygen will get a positive charge. So oxygen is getting positive charge, but this is something we can easily remove H2O plus good leaving group. Right? So what you get is something like this. This group will leave, and what you get is something like this. Right? So this bond will break and H2O will leave. This will break minus plus here. Yeah. Correct? Or if you want to form a bond here, you can also get something like this. This double bond N. Correct? You move electrons from here to here. Correct? Two electrons move from here to here. This is what you'll get. Now if you see from here, removing nitrogen is very easy. Correct? This bond will break. This electrons will move from here to here. So you get R plus and nitrogen gas. So you remove nitrogen actually. So you get carbocations here. You get R plus here. And once you have R plus, you can easily attack OH minus here to get ROH. Hope you understand what I'm trying to say here. Little easy, difficult, let's understand. I have this primary amine. I have this HNO2. I told how you form. You take NaNO2 and HCl. Now what happens is HNO2 reacted with H plus, you get NO plus, nitrogen ion first. Once you have that, you react this with primary amine. Right? So primary amine, if you see, has a lone pair attracted this positive charge, you form this compound, and then this tautomerization happened, and you get this. Now we want to get rid of N2, so first get rid of OH, add H plus here, it will take this OH out, so this whole H2O is out, so you get something like this. Now it had lone pair, you move in this direction, you get this. Now in this I can easily remove N2. I can easily remove N2, I get carbocation. Carbocation once I have got, I can easily attack with OH minus to get ROH. Correct? So we'll try to understand how to prepare alcohol from Grignard reagent. So here we take aldehyde or ketone. So aldehyde, if you want to form 1 degree or 2 degree, 1 degree I'll form methanol, I'll take, and or ketone if you want 2 degree, and then I'll use Grignard reagent. I'll use in presence of dry ether. I'll get some complex compound. In that I'll add water. With this I'll get alcohol. Correct. So I'd use aldehyde or ketone. Aldehyde for 1 or 2 degree. So for 1 degree I'd use methanol. Methanol actually, or formaldehyde. And 2 degree I can use any other aldehyde. Maybe ethanol, propanol. Ketone I'll use if I want to form 3 degree alcohol. Use Grignard reagent in presence of dry ether. I'll get some complex product. I'll add water. I'll get ROH. Correct. So let me show you the reaction mechanism here. So let me take ketone to be a general one. R1, R2, let's suppose. I'm reacting with Grignard reagent RMGX. So we know that this gets negative charge and this has slightly positive charge. This is something we know, Grignard reagent. Oxygen is more electronegative, try to attract electron toward itself. Slightly negative, slightly positive charge. This guy has negative charge. This is positive. So this negative will attack this guy. This is negative, this is positive, it will attack this guy. In presence of dry ether, we don't want any OH minus here. So what you formed is something like this, O MgX, and here you get R. And this is a very unstable, this is called adduct. On this you add H2 water, right? So what you get is, the moment you add water, this MgX OH comes out and this water H is getting added here. So what you get is something like this, plus MgX and OH comes here. So MgX OH is something you get, and this is the output you get. This is the typical reaction for preparation of alcohol. This is alcohol from Grignard reagent. So I took aldehyde or ketone using Grignard reagent, dry ether. I got this complex. On this I add water. I get my alcohol. This is my alcohol. So let's see the preparation of alcohol 1 degree from the Grignard reagent. We told that for 1 degree we'll use only methanol or formaldehyde, right? So let's use this. So we have this methanol actually, or formaldehyde. So when it reacts with RMGX, let's see what happens. This is plus, this goes off, slightly negative, slightly positive. This slightly negative, it will attack this carbon, and this carbon is slightly negative, it will attack this MgX. So what you get is HCOMgX here you get R, and here you get H. This is again adduct. Now this, on this you add water. So what you get is here R CH2OH and MgOH, and X is something you get out. This is what you get. And this, if you see, is a primary alcohol, 1 degree alcohol. Or directly what you can do is, you have the RMGX, Grignard reagent, use dry oxygen and use some water, directly you will get ROH plus MgXOH. This is direct. So in both cases you get primary alcohol. You can use any of these methods to get primary alcohol from Grignard reagent. Either you react with methanol or you directly just react with dry oxygen in presence of water. Let's see the same thing for secondary. For secondary, I told we can use any aldehyde other than methanol. Any aldehyde minus methanol. This will give you a secondary alcohol. So let's suppose I have this R1COH. This is my aldehyde. Same reaction, RMGX will use negative charge, slightly positive charge, negative charge, positive charge. This will attack this carbon. This oxygen will attack this MgX part. So what you get is R1COMgX. Here you get R and you get H. This is again adduct. On this you add water. You get RCH2, sorry, RCHOH R dash plus MgX OH. If you see here, this is my 2-degree alcohol. Correct? You can take CH3COH, C2H5CH, you can take anything. For preparing 3-degree alcohol from Grignard region, we use ketones. You've seen this example here. Let's take a more specific example. This is a ketone here, and let me react with CH3MgI. The generic example we took past 2-3 slides back. We took this. This is like oxygen is slightly more electronegative. It will get negative charge. It will get positive charge. Here it will have slightly negative charge. The whole thing will have slightly positive charge. This negative charge will attract this carbon. Slightly negative charge will is MgI. What you get is CH3, O, MgI, and here you get CH3. And this is adduct again. On that you add water. The moment you add water, you get CH3, 3 places CH3, you get OH, right? This bond will break actually. Bond will break OH plus MgIOH. This is what you get. If you see here, this is my 3-degree alcohol. This carbon has 3 carbon attached to it. This is my star carbon. Correct? As I told, one more method to prepare alcohol is fermentation of carbohydrates. So carbohydrates, if you do a fermentation, you get ethanol. This is generally used to prepare ethanol. So I have my C12H12O11. This is my carbohydrate. I put some water and I give some yeast. So I get C6H12O6 plus C6H12O6. This is glucose and this is fructose, which has same structural formula. So I can take any of these now, glucose or fructose. Now I get 2C2H5OH and CO2. This is my ethanol. See, if you see the whole process, there are a lot of things here. See, the first thing is water is added. Why water is added? See, if you don't add water, the yeast cell won't grow, right? See, yeast cell cannot live and multiply in concentrated sugar solutions. Concentrated sugar solution, the molar is actually, the yeast cannot grow. So water is added, right? Also, small amount of ammonium sulfate and phosphate is added because there is nothing but food for this yeast. And you also make this whole solution slightly acidic so that other undesirable bacteria don't grow, right? The whole thing is kept in the temperature range of 300 Kelvin plus minus 2-3 degrees actually. So it is in this temperature range it is kept for the fermentation, right? So the enzymes in the invertase enzymes that is present in the yeast, they decompose this sugar into alcohol and it gives carbon dioxide, and this the whole thing takes 2 to 3 days. So if you see the first reaction, you need invertase. In the second reaction, you need gymase. Right? So these are the enzymes that is present in yeast. So yeast has two enzymes. One is invertase, other is gymase. Correct. So this is the whole process. You have the yeast, two different enzymes. You keep the temperature in the optimum range, and then it takes 2 to 3 days. And this invertase converts the sugar into glucose and fructose. The same glucose and fructose is used by gymase to convert into ethanol, and carbon dioxide is liberated out. This is the typical reaction. Now we'll take some numerical. So we have to give the structures in the IUPAC name of the product expected. The first is catalytic reduction of butanol, meth-eth-pro-but. This is my butanol. If I do a reduction using LiLH4, what happens is this becomes CH2OH, right? That's what you have seen. This is gone in this direction, and you add H in both sides. So what you get is OH. You can add extra hydrogen. This is what you get. This is butane 1. Correct. What happened here is this is hydrogen. You add one more hydrogen, so it becomes CH2OH. So if you want, I can add hydrogen here just to make it a little clear. The next is hydration of propene in the presence of dilute sulfuric acid. With propene, you can take this bond, double bond, doesn't matter, you'll get the same thing, it's symmetrical. So this is propene. I do a hydration in presence of dilute sulfuric acid. So what happens is, so here if you see the carbocation is formed, and based on the Markovnikov rule, you add hydrogen and oxygen. The Markovnikov rule says that the carbon with the least number of hydrogen will add OH. So here if you see this carbon has the least number of hydrogen, right? If you see both the double bond, right? So here you'll add OH, here you'll add H. So what you get is CH3, CH, you add OH here, and here you add H. This is my meth-eth-pro-propane 2-ol. Correct. The next is the reaction of propanol with methyl magnesium bromide followed by hydrolysis. So I have propanol. This is my ketone propanol, methyl magnesium bromide CH3 MgI. Yeah, bromide MgBr. Yeah, methyl magnesium bromide followed by hydrolysis. So if you see in this case, there will be added form, minus plus, and this will be slightly negative, slightly positive. So this will be attracted here. So what you get is CH3, O, Mg, Br, and C. Right? And then if you add water to it, so you get C, and here you get OH plus Mg, BROH. Correct? This is what you will get. This will be 1,1 dimethyl ethanol. That is what you will get. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.